You're gonna put this up on the site, right? The slide deck.
Oh yeah, yeah. I'll do it tonight or tomorrow. Again, it depends on how long Zoom and YouTube take to convert the video. All right, so here's what we got a lot to do tonight. I'm going to try to keep the data wrangling. I'm going to be very quick. So you're going to have to interrupt and ask questions because I don't want to stomp on Andy's feet or, his course too much because I think that's a lot of what's going to go on there. But in terms of descriptive stats and variable types, which is kind of relevant to statistics, I want to talk about that. And then I'd rather spend more time on data visualizations. So just real quick, if there are questions lingering from last week, please chime in. I did a quick word cloud here based upon your responses to the 1-minute papers. I'm hearing my echo back. Let me see. I'm just going to mute. Feel free to unmute if you need to. I'm just, I don't know who it was. So on the left side, I'm happy to see some of these words about sampling and blocking and data. So unremained questions. So questions is obviously one of the more common, the most frequent word. So some questions about RStudio looks like might still be remaining and some other things. So if you had something specific, I'm happy to address it now. Otherwise, chime in as we go, or maybe as we start working through this some more, it'll make sense. We have 4, I'm sorry, presentations. Start with, did I copy this wrong? I think I might have. Is it Foy? Why do I feel like I messed up on the Google Sheet? What about Claire? Are you on?
Yep, I'm here.
Okay, so I have to stop sharing and you can now share. And I'm going to go check while to see what I screwed up on that first one.
Okey doke.
No, it just says, oh, okay. All right. So we're actually only, okay. Go ahead. I'm sorry.
No worries. I have to allow Zoom access. Okay. I think I have to quit and rejoin Zoom to reset my system preferences.
Oh, okay. No problem. How about,
I'll be right back.
No worries. David, are you on?
I sure am, yeah.
All right. Why don't you go ahead?
All right. Hopefully I did this right. Let me share my screen. So let's see where share screen. And then slide. I'm just trying to remember what present is. You guys remember where it is?
What are you looking for? We can see your screen.
Yeah, I'm just looking for the present button.
It's big enough if you just want to leave it in this view. It's up to you.
Okay. Oh, there it is. Okay, so hey guys, I did question 1.31. So giving it my best shot. So I want to start by breaking down just what the question is. Essentially, it is kind of a meta-analytical question where it's really looking at what the parts of studies are. So in this case, it was looking at the effect of light level and noise on exam performance of students. And there were 3 main questions to it. What type of study is this? How many factors are considered in this study? And what is the role of the sex variable in the study? So to go in order, question 1 is what kind of study is this? So really you can tell just by looking at the question itself. So I marked the relevant parts of the question in red so you can really derive where that information comes from. So here we can see exam performance is the main thing about the study. And yeah, as mentioned, this is just based on what the initial question is, how it explicitly says exam performance is the key thing that we're studying. The second question is how many factors are considered in the study and what are their levels? And there are really 2 main. There is light level, and 2, there is noise level. And much like A, you can just see it by reading the question, how it says the effect of light level and noise. And the levels for part 1 are fluorescent overhead lighting, yellow overhead lighting, or no lighting, which is effectively kind of like what the natural lighting of the room is. And levels for 2 are no noise, construction noise, and human chatter noise. And then the final part of the question is, what is the role of the sex variable in the study? So sex is important because the researcher wants to see if it plays a role in how people react. And so this would really be the blocking variable. So when you're breaking everyone into groups, that's going to be the main way you're splitting your audiences is primarily by gender. And then you're going to be breaking it into those variables that we described in question B or in part B. And then this is the part where it just says has a different effect on males and females. So it wants to make sure that they're both representing equal treatment.
Great. Thank you very much.
Yep.
Claire, I see you're
Anyone
back.
have any questions about anything?
No, it's good.
Yeah, I can try. Let me try one more time.
Sure.
Alrighty.
There we go. Yeah.
You
can
see?
it. Yep.
Awesome. Awesome. Yeah, so I took a look at question 1.21, internet use and life expectancy, and I was mostly drawn to it for the name as a fervent internet user. So essentially this question was taking a look at this scatter plot and then asked a couple questions about the relationship between those variables. So the following scatter plot was created as part of a study evaluating the relationship between estimated life expectancy at birth, which we can see on the y-axis here, and percentage of internet users, which we see on the x-axis in 208 countries for which such data were available. And so there were 3 questions. Describe the relationship between life expectancy and percentage of internet users. What kind of study is this? And state a possible confounding variable that might explain this relationship and describe its potential effect. So for the first question, describing the relationship, I thought this was a positive relationship, but it didn't seem exactly linear. But it seemed that life expectancies were higher with at least some amount of internet usage. So you can kind of see in the chart over here that these lower life expectancies were really kind of clustered in this 0 to 10% window here. And then from there, it seems like it still might increase. This is my attempt at a line with Sheets curve tool. So it's really scientific here. But it does seem to sort of end around the 80-year mark. And this was an observational study. Obviously, I think logistically, it would be really hard to configure this as an experiment, hard to hold everything else equal, but withhold the powers of the internet from some subsection of the population. And as far as confounding variables, the one that stuck out to me as kind of most likely was just resources. I think having access to internet implies there's some infrastructure in place. And if you live somewhere that has that infrastructure in place, potentially there's also access to better healthcare, better nutrition that might have a little bit more of a direct effect on life expectancy.
Great, that was great.
That.
Let's see, Trang.
Hello, hi everyone. Let me share my screen. Can you hear me?
Can hear you. Yeah, we can hear you good.
Yeah. Okay. My question is the question 1.43. The Stanford Open Policy Project gather the information about and analyze about the traffic stop by law enforcement agency. So this is the table of the data collection, and there are 3 questions about it. The first question is what variable were collected on each individual traffic stop in order to create the summary table above. So just like you see that we have the variable county, the first one, and the second is state, and then driver race, and cautious when a stop happened, and then another thing is that the driver will be addressed during the stop or not. That's the variable ID I found. And the question B, the test whether it variable is numerical or categorical. So for the test, I see that it's a categorical and it's not ordinal, just like the character. And the question number 3. Suppose we want to evaluate whether vehicle should rate are different from driver of different races. So it did analyze it. Which variable would be the response variable to response variable, and which variable would be the explanation variable? I think the rest would be the explanatory variable, and the percentage of the stop question is the response variable. So that do you have any question if I'm right or wrong?
No, that was good. Thank you very much.
Thank you.
All right. So let me see here. Now my chat window went away. Hold on a second. Yeah, thanks everyone. So Foy posted the link. I must have, the link wasn't there when I copied it out. So you can later on watch that on your own, which is okay. All right. So
can I just ask a quick clarifying question about
yeah.
that? So, okay, so I think the problems that are supposed to be presented are just non-assigned problems from the open intro book, right?
Yeah. Yes.
Okay.
Yeah.
Got it.
Yeah. So which I say odd numbers, but I guess technically if you want to do non-assigned, if there's an even that's not assigned, that's fine. Yeah.
Okay.
Yep. All right. So I don't know how many people have seen this figure. Is there a, well, we don't have to worry. So a couple of people have video on, so thank you. So this is from mostly, I think, Hadley Wickham, and then the R for Data Science book that he wrote with Garrett. This is sort of the framework I think that RStudio takes and kind of communicates, but I think it has a broad applicability to data science, right? And so this course, and I think we talked about like Conway's data science Venn diagram, and like this course is clearly in that statistics kind of, mathematical quadrant or circle. But, we're going to touch upon a bunch of other pieces. And, tonight, I think we'll talk a little bit, I don't know why I went back to the beginning. Tonight we're going to talk about like a lot of transformation and visualization, and then the rest of the semester will really be digging into getting to this point where we can model, or what the foundations for that modeling is. Communication, I think I try to cover there. Our markdown files is sort of one way that you can communicate. I think doing, these short little presentations each week is a way of communicating, and they're going to do a larger presentation at the end of the semester, which I think is kind of a critical skill. So I'm just going to go through this, and I'm going to trust that you can chime in and say slow down in the chat, or just speak up, because I think a lot of this should be content that you're going to dig into much greater detail in 607. I'm just going to highlight the bits and pieces that I think are relevant to statistics. So, we're talking about tidy data. When we get to modeling, right, we want almost all of the modeling techniques you're going to use, or predictive models, whatever it might be. Generally expect your data to be in this tidy format, and really it's about each row representing an observation and each column representing a variable, right? And that's pretty key. We'll do some reshaping of data from time to time, particularly when we do visualizations. Sometimes we need to reshape it into a non-tidy format, or sometimes what's called a long format, and we'll cover that when we need to. But this is sort of the expectation that we want to get to. Now, kind of two broad kinds of questions, and when we get to modeling, in fact, I've been looking at this. Arthur just shared this little diagram, which I find kind of interesting, which is sort of picking kind of algorithm you're going to use, or kind of method you're going to use, and one of the pieces early in the decision tree is, are you predicting a category? And that comes down to this, whether you have a categorical or qualitative variable, or a numerical variable. And we're going to pick different techniques depending on those. which one we have. And that's going to start tonight when we talk about descriptive stats or even visualizations, right? That the type of variable is going to matter. I think a lot of this is probably intuitive to many of you. A couple of things I'd like to point out though, like you got to be careful between discrete and ordinal, because I think these are often confused, and sometimes ordinal data is considered continuous or quantitative, but it probably shouldn't be. So the classic example is like any kind of Likert response survey that you might have. If you calculate a mean on that, and in fact, when I get course evaluations, I just got my course evaluations from last semester, and they give me a mean score, and I'm like, well, I really want to look at the breakdowns by categories, because when you calculate a mean, you're presuming that the intervals are equal. And in the case of like Likert data, where you have, say, neutral to agree, I would like you to think about like how you respond to these surveys. How much evidence do you need to have to be compelled to go from neutral to agree? And then think about how much evidence you need to have to go from agree to strongly agree. Speaking for myself, right, it takes a lot more. It's pretty unusual for me to go to strongly agree in a lot of these kinds of surveys, right? I need a lot more evidence of weight. So that interval is much larger for me to go from agree to strongly agree than to neutral to agree. And so that has implications when we start talking about it in terms of modeling, in terms of describing it and visualizing it. So that's one area that's often kind of confused, but the rest are probably fairly intuitive, and we're going to spend enough time with it as we go through. Now, thinking about variable types in R and how they're going to be represented in R, this is a figure I created. So R has 5 primitive types, right? You have logicals. So if you come from another programming language, sometimes logicals are a first-class type, and sometimes they're not. Like in Java, I don't believe they are. They're kind of stored underneath as really just a 0, 1 numeric, integer vector. But in R, a logical is truly stored as true false. It's separate from an integer. And integers would be our whole numbers. Numerics are our real numbers. Rarely seen, but R does have a type for complex numbers. So all the times you encounter the square root of -1, you can now represent that, and then characters. Kind of put it in this order, right? So each of these, right, and the other thing, if you haven't realized in R, right, so these primitive types, unlike other languages where you have a scalar and then you can kind of have arrays or lists or something, in R, these are vectors. So even if it's like one element, there are really no scalars. It's just a vector of length 1. So which means you could, if you assign a number in R, it has, other attributes like a length, right? A simple scalar wouldn't typically have. So you have these as and is. As is a way to convert, coerce something into that type, and is a way of testing if it's that type. And that can be important because, for example, like, we're going to do logistic regression at some point where we want to predict a true false outcome or a dichotomized outcome. So you're going to probably bring the variable in as true or false, but when we actually do the modeling technique, it's actually going to be converted to an integer as a 0, 1 integer, which is fine because we don't actually lose any information. So oh man, there's something been going wrong with my trackpad, and it's kind of annoying. I just need to put it away. So in this case, as you convert from the bottom up, you're actually not losing any information, right? Because we can kind of consider a logical as an integer, 0, 1. 0, 1 is fine in the real number systems, right? If it just has no decimal information, right? Complex, there's no imaginary part, and we can even store it as a character. We can just put quotes around it, right? But as we try to go from characters down, we're very often going to lose information. And so if you do those conversions, you just need to be a little bit careful. So, in the case, if you have a numeric vector, right, with zeros and ones, and you say as logical, R will do the right thing. But if there's any other value other than 0 and 1, R is just going to kind of assign that as a missing value. And NA is the missing value in R. Okay, so things like factors, which we'll use quite a bit, are really just integer vectors with a few other little attributes associated. So it just says, well, 1 is equal to males, 2 is equal to females, 3 is equal to, other. Similarly, dates are simply just the date format is the number of, well, it depends on which one. There's a couple of different versions, but most of them are the number of milliseconds since January 1st, 1970. But under the covers, right, R is just storing that as an integer vector. And then we'll get into data frames, lists, and vectors as we move along. A data frame is really just a collection of vectors, right? A list is just a collection of anything, right? And then these are all just kinds of vectors. So this is kind of another way to think about it. But these are the primitive types in R, and it's the things we're going to work with the most as we do modeling. All right.
Jason?
Yes.
What's the difference between a list and a vector in R?
Vector is one-dimensional, and it's one of these types, one of these 5. So a vector can only contain a character, a complex, a numeric, an integer, or a logical. A list
So you cannot contain multiple data types in a vector?
No.
Okay.
No. A list, well, there is an array that allows you to do that. But I almost never use an array, so I actually forgot to put it on here. A list is one of the more common ones. A list can contain literally anything. It's, you can have lists of lists. So if you ever work with like JSON data, for example, where you have like nested documents, or if you end up using like the JSON Lite package is something I use from time to time, and you read that in, it often comes in as lists, and because you can have elements nested within elements and kind of just traverse down that way. We won't use that too much here, but but that's a good question.
Is it I remember when I was doing the exam for this, I was reading, is it really true that there's no dictionaries in R? I know you can kind of get around it by nicknaming integer or indexes in a list, but I didn't know how true that statement is when I saw it.
There's no
dictionaries.
You mean like
no key, like a list with a key value pair?
Oh, no, there isn't. Oh, well, kind of. I mean,
you could create your own map, right?
Yeah, you could do that, and I mean they have row names and the like.
Yeah.
R is it's a vectorized language, so a lot of the operations are done on the entire vector at once.
Mm-hmm.
So it's designed to do those kinds of operations. So doing lookups in that way is, generally not, that's not what R and its predecessor S was designed to do. So,
Gotcha.
Yeah. So if you have like really large data like that, and R is also memory bound, right? That is potentially one of its limitations. Although nowadays, I rarely encounter that, that issue, because swap memory and with 64-bit processors, and it's usually not that big of a deal. If you have data so big that it won't fit, you can't address it all, then those are like the Google, problems Google and Facebook are facing, right? Where you have giant distributed systems. That's a whole other degree program to. But anyways, I'm sorry, I'm digressing. So yeah, there's really no lookup. There are, so data frames and matrices can have row names, and of course they have column names. And so, you can look it up that way. As far as the speed to do that, usually just reference them by integer or by position. And because like logical operators are going to be vectorized, they tend to be pretty fast, even though you're not doing a lookup in sort of a traditional database sense.
Would we ever have
Gotcha.
a scenario, like the complex similar to something what we have object in Java?
No. Complex is like a complex number. So where you have, so it's actually a two-dimensional number space, right? Where you have the real numbers often represent on the x-axis, and then on the y-axis you have the imaginary component. So that's a case where, so I, which is the imaginary unit, is equal to the square root of -1. So think, as an undergraduate, I did a lot of work with like dynamical systems and fractals and chaos theory. right? And so that's a lot. If you've ever seen the Mandelbrot set, that's, you know, working with complex number systems and statistics, we're almost never going to use it unless you go into something like electrical engineering, or you're really, you know, if you're going to be a data science with electrical engineers, being able to represent a complex number will be important, but it's just here for completeness sake. I wouldn't even worry about it.
All right, thanks.
All right, so this table is sort of my attempt to mapping the data types to, you know, the typical descriptives. This is by no means exhaustive, but is a good place to start. And we're going to dig into a lot of these over the coming weeks, and then sort of some of the key visualizations I would use for those types. So if you just have one continuous variable, right, mean, median, mode, standard deviation, interquartile range are all sort of appropriate measures, right? So mean and median and mode kind of being measures of center, right? Standard deviation and interquartile range are being measures of spread, right? So when we talk about continuous variables, we care about the center and we care about the spread. So histograms, density plots, box plots are all kind of appropriate. When we have discrete, you know, variables, you know, contingency tables or proportional tables or the median are certainly appropriate. Mean maybe a little bit less so. Categorical, we're just going to really look at contingency and proportional tables. And a bar plot is sort of one of the key ones. Same for ordinal. And then we have, excuse me, a situation where if you have like two quantitative variables, sort of our descriptive stat of interest will typically be the correlation. Scatter plots are very appropriate. If we have two qualitative variables, you can do a two-way contingency table. We can look at a chi-squared test for fit that we'll talk about in a few weeks. Mosaic plots and bar plots are appropriate. But then if you have one quantitative, one qualitative, you can do group summaries. There's ANOVA t-test that we'll talk about. And then box plot is sort of my go-to visualization in those situations. So let's get on. So,
could I just, so why wouldn't you use the mean for discrete? Like, you know, we usually use the mean for weight or height or,
well,
I guess weight and height aren't really discrete, but age, you might use mean age.
Yeah, age is probably appropriate because there's enough, but if you have, you know, if your measure only goes from like 1 to 5 or something.
Oh, sure. Okay.
Yeah. So it's really about smaller values. Then the then you're going to, your mean is going to be, you know, probably not a valid value or a value in your system. Right. So actually I know I have a, you know, coming lecture when we talk about probability and right. And we're going to calculate, we're going to have probability of these events where you pick a number of cards and you're going to say, well, it's going to take me 2.7 cards to win. Well, you can't pick 2.7 cards. So then we always have to round up in that situation. So that's where the mean, you got to do a little bit more with it. Right.
Okay.
So, good question. All right. Just one thing, because you'll see this language used a lot, this notion of robust statistics. So the median and interquartile range are the two measures that are considered to be the most robust. And the reason why they're the most robust is that they are the least sensitive to skewness and outliers. Now, unfortunately, almost everything we're going to do in this course is working with means and standard deviations, right? Which is why we're going to spend a lot of time worrying about whether or not the distributions of our data and what do they look like and are they appropriate to use these measures. In a descriptive way, I almost always prefer median as my measure of center when I can use it. So the classic example that I always give is if I took a poll right now and asked everybody what your annual salary is in 2020, coming up on tax time, right? And I averaged it, we get some number. And then, imagine what that is, and you can be as generous or not generous as you want. But then imagine Bill Gates comes and joins our, or Elon Musk comes and joins our course, and we add his average annual salary into the average of the whole class is going to skyrocket, but the median is going to change hardly at all because it's just kind of the middle value versus taking the average of all the values. So, picking robust measures is going to be important.
Would you, I was thinking about this when I was doing the homework, and your slide kind of reinforced it. I just want to check. So would you say that really if you find a data set and the mean seems like the most appropriate metric, you should use standard deviation and vice versa for median IQR.
Yeah,
Is that
that's
a good rule of thumb?
Yeah, that's a good general rule of thumb because the box plot is really using the interquartile range. So we'll see that in a minute. So that's the visualization that goes along with it. So, and sometimes I mean, I always report them both. And I like to see them both because as a quick check, if the mean and median are wildly different, that's usually a good indication that there's skewness. And Richard, really, Elon Musk only claimed $23,000 in salary. Yeah, that might be right. I remember Steve Jobs always took $1 salary from Apple for years. That's funny. So that's a bad example. I need to find another one. I guess maybe it would be income. I need to, what's your annual income, including stock options or net worth? Yeah. Hopefully you get the point. So report both. And if they're wildly different, that's a good indication that there's skewness in the distribution. So, all right. So this is the package I wrote this weekend. I've been using a Lego Sets data set for a long time, but it was wildly outdated. So I decided to just fix it up myself. So if you want to install it, you can install it off GitHub using this command and can play along. The primary way I'm going to use it is I actually pre-built the data set in the package called Lego Sets, which includes 16,355 observations. Basically, every Lego set Lego has released from 1970 through 2020. And these are the variables that are in the data set. So we can do some, try to make this a little bit fun. Lego is a big thing in our house. I have 3 boys, as I mentioned. And in fact, you might even be able to see over my shoulder. Oh, no, it's kind of just out of view. On my shelf, I got for my birthday. I got the original NES Lego set, which was fun. All right. Anyways, if you like Lego, there's a bunch of functions to interface. I'm thinking about writing up something to do you can get reviews, and that might be fun to do some textual analysis. So when I begin with the data set, I often use the str function, which is short for structure. I find this really valuable to kind of see what variables are in there, what the column types are, or at least how they came in. And it gives me the first few values of each one. Of course, now with RStudio, the environment tab really gives me all the same information. So I still find myself typing str quite a lot. But this is pretty useful too here. So you can kind of see what your data looks like. So here's a quick table view. It's not complete. I kind of truncated it to get it to fit. And I also randomly selected 100 values, but you get a sense of what the data is. We're going to really focus in on things like retail price and pieces as a visual cue. I'm sorry. Okay. Okay, so I put this here. If you haven't already discovered, I think I posted a link in Slack, but just to reiterate, RStudio has a page with a ton of really great cheat sheets. They're all usually about 2 pages. So here's a link to their dplyr, which is sort of the tidyverse approach to manipulating data. So I think it's worth having this PDF on your desktop or close by. And then I'm going to put this in here because if you're new to R, or if you came to R from one of these different structures, right, there's kind of different philosophies to working with data in R, right? So the far left column is what's here. It's kind of labeled as the $ syntax. I often call it the base R approach because this is the way like the core R language is designed to do it, to subset data and vectors and the like. The reason why it's called, I think this person labeled a $ is when you want to get a variable out of a data frame, you do the data frame name $ variable name. And I still use it quite a lot. So I am very slowly trying to come up to speed with the tidyverse syntax, which is the far right. So in this slide deck, I'm actually going to show how to do both approaches for most things. There's this middle syntax, which is the formula. We are going to use the formula syntax only in terms of modeling because it makes sense to me there. But the lattice approach of plotting is kind of fallen behind what ggplot2 can do now. So, I just wanted to make that aware. Throughout the semester, I will kind of switch between the two, depending on, sometimes it's quicker for me to do something in the tidyverse syntax versus the $ or the base R syntax. And this came up, I think somebody was asking or posted a link about pipes, right? And so this is a kind of a key piece to how the tidyverse kind of works together and kind of connects pieces together. In short, right, what a pipe does, and this syntax % greater than %, and I should note, I think I might have posted it in the Slack. There's actually going to be a pipe in R soon. I think the next point version of R will have its own pipe, which I think was vertical greater than is going to be the kind of built-in pipe. So you won't have to actually load the magrittr package, or if you load the tidyverse package, you're kind of getting this along. But in short, what this is doing is it's taking the output from the left-hand side and passing it as the first parameter to the function on the right-hand side, right? So if we look at in sort of the base R way to do it, if we wanted to do a proportional table in R, right, it's a two-step process. First, we need to get a contingency table, right, which is done this way. So I'm taking the category variable in the Lego sets, and you can see the $ here, right? So I'm pulling out, so the table takes a vector, right, as a parameter. And I'm going to save that into a variable called tab out so that I can pass that as a parameter to the prop.table. Right. So that's one way you could do it. If you want, if you are stingy with your lines of code, you can just nest the table inside a prop.table, which is fine. This is the way I've been doing it for 15 years. It is a little bit hard to teach because what you end up having to do is read from the inside out. So I'm taking the Lego sets, taking the category that's going to the table, and then that's kind of right. Versus here, I'm calling my the table function, which is going to give me the contingency. The output of that is going to be passed to the prop.table. And you can just kind of chain these along. And hopefully, I kind of agree that it's a little bit nicer and that you can just now read left to right, which is probably a little bit more natural. Some people get hung up on is like prop.table still needs a parameter. You're not, so that first parameter is always going to be set by the pipe operator. So you need to be wary of that. R is also another strange language in that you can pass parameters anonymously. So you don't actually have to, right? So there's a parameter, if you look at the documentation, actually I can do that right here. So if we look at, let's see here, if I just type table, it'll give me the source code. Well, of course it's using the dot operator. So that's kind of a bad example because you can have more than one parameter, but I don't want to go into that right now, but there's usually a variable assigned here, but you can assign parameters by position, but you can actually put them in any order as long as you do label them. So I tend to, just as a stylistic thing, always assign my parameter value. So I'd say, parameter value 1 equals what I want it to equal to. So it's very clear. But the point, all three of these result in this exact output. Okay. Questions about the pipe?
Is this like how R does methods?
No, that is a R has at least 4 different object-oriented programming frameworks.
Okay.
The notion of a method in sort of a typed language like Java or C++ doesn't, I mean, there's the R4. I kind of want to, I would be happy to talk about this. I don't have it in a curriculum, but maybe it as a side conversation, or maybe after, class some night, I can go in a little bit to at least the S3 approach, which is kind of the core way, which is really just by convention. That's sort of the typical object-oriented programming where you would have methods. And it might be good to understand that at some point, but so yeah, there's no it's a little weird.
Yeah, that's why I asked the question, because I know like R doesn't support object oriented, at least like in base. So, but this like how it's functioning to me, like it just looks like how a method would
Yeah.
function in an object oriented language.
Yeah, I wrote a blog post a long time ago on I've been really bad at keeping this blog, but up to date. Can I find it? Yeah, here it is. So I'll post this in. I don't know how, because I kind of, so I wrote a package where having, and I came from a Java programmer. So this kind of describes an approach to object-oriented program that I like, that really, so I just define a function, which is sort of my constructor, and then you have a list within, which are my attributes. And then you can, right, so you can see NC is what's going to get return, and I'm defining functions on my object. And so anyways, you can, it's short, you can read through it. So this is one way you can do it. This is very close to, how R3 works, but it's a little less formal than R3. But it's, yeah, it's kind of complicated. All right, where are we? 9/11. Okay. Filter, is a way of just selecting rows. So as a review here, is just kind of review the logical operators that we're going to need to have. So the explanation point is the not operator. So if you ever want to negate something, just put an explanation in front of it, mark in front of it. Logical comparisons, you need to have two equal signs, right? So that's going to return true if A and B are the same. You can use explanation equals for not equals, greater than and equal, probably pretty self-explanatory, less than and less than or equal to. This one's really, I use this quite a lot. This is really, to me, really useful. And this is almost like a kind of an OR operator is one way you can think about it. So what's going to happen is for each element in A, it's going to go through and it will be true if that value exists anywhere in B. Right. So here's the example I like. So if we have letters, which is just the vector of A through Z, I want to, the first part, what this is going to do is just going to return a vector of equal length to letters, right? So let's look at, so if we have letters, right? And then if I do this, you can see I get a logical vector of length 26, because that's how many are in my letters, right? True at the place where I have the vowels, right? And then I guess I can then, what the which function does is just gives you the indices of that vector where the value is true, right? So this is kind of really, really handy. I use this all the time, where like if I want to, so on that 1 minute paper, that little visualization, I could pick certain topics if I want to pull all the responses, because they're all going into one Google spreadsheet. I could subset it and say, give me the ones where the topic is equal to this, or this, right? That's kind of how I would use it. So we have OR operators, which is the vertical line or the pipe character, and the ampersand is the and. So if we want to kind of do some logical conclusions, this is going to be true whether you use the base R approach or the tidyverse. So here, I want to pull out all Lego sets where the theme group is equal to educational. So what I do here is, here's my data frame. I'm passing it to the filter function. The first parameter of the filter function is a data frame, right? And then the rest of it is, the second parameter is just going to be my logical operator. So here I could say, well, I want theme group is equal educational, and the set was released after 2015. So in base R, the way you do it is you use this square bracket notation. So with the data frame, because it's two-dimensional, you're always going to have something, comma, you're going to have rows, comma, columns. And if you leave it blank, so you can see here, I have nothing after the column, that just tells R return all the variables, right? If I had nothing, comma, and a column name, then that would return all rows, but those subset of columns. So the parts here that are a little bit complicated, right? Because I can't just say, in the filter theme group, I'm not, it knows that it's from this data frame, but from base R, I kind of have to spell it completely out. So I have to say, well, it's this vector is equal to educational, and it's this vector is equal greater than 2015. But either way, they both result in 61 rows being returned.
Professor Breyer,
Yeah.
question for you. In the filter command, does the ampersand also indicate bitwise operations?
Oh, no, I don't know if you can do bitwise operations in R. I don't think you can get to the bit level. It's always a byte at minimum.
Thank you.
Yeah.
I was just curious for the in operator, is there a not in? So if you wanted everything but the vowels that were in that list?
Yep. Just put an exclamation point right here.
Oh, okay. See, that's where you put it?
Yeah, because this whole thing returns a vector that becomes a vector. So if you put a not, the explanation point, the not operator, it just flips all of those true falses.
Awesome. Okay, thanks.
Yeah, well, here I'll show you. So it's, I think, worth just looking at, right? So if I just put, right, I'm sorry if the text is a little small. So we got, it's all exactly reversed. All right, cool. Good questions. Select is a way of getting columns. So looking at the base R first, right? So here, I have nothing to the left of the column, the comma. And that's because I want all rows, but I want these columns. In the dplyr approach, I just use the select function and I just list them out. I've been doing some work recently. This approach has been fantastic because you can do, look at the documentation for select, because you can do regular expressions and you can do like starts with. So, or I think, I wanted to group things. So I wanted all the character columns and then all the integer numeric columns afterwards. So there's, look at the help documentation. There's all sorts of fancy things you can do that I just don't want to spend time tonight getting into. And it's not really going to be necessary for this class, but this function has really impressed me. But this is the output here. I'm just looking at the first 4 rows of each of these, so you can kind of see how you do these rearrangements. With select too, you can do things like if you put an explanation point in front of the column name, it's basically select everything but that, right? Or so that's a great way if you want to drop columns. If you have so I often do that. I get these educational data sets that have so many columns, and it's like I'm really only interested in like 8, and I subset it just to make it a little bit easier to manage. Oh, here it's the relocate. Well, the relocate kind of shares some stuff. This is a way of just rearranging it. Again, not really only useful if you're going to display the table in a way. So this is the example. So here I'm moving all the numeric columns first, and then afterwards I'm putting all the characters, and you can see the first 3 rows. Of course, in base R, I kind of just got to do it manually. I got to figure it out myself. Rename is kind of really handy, right? If I just want to rename columns. So here in the, the tidyverse approach, I got new name equals old name. And here I just want to rename one column, right? I want to change US_retail price to just USD. You can see how it's changed here. In base R, right, there's a names function that you give a data frame that returns a vector of the column names. And I have to know that the 5th one is the column I want to change the name, and I can do that, right? So it's a little less, this is a little messier for sure. All right, mutate. If I want to create new variables, so one in the Lego world, when people evaluate Lego sets, the price per piece is a common metric. So let's we want to calculate that. So first thing I'm doing here is actually filtering out all rows that have missing pieces or retail price. So that's the is.na. So na is the value for a missing, it's a missing value, which is an aside. I had another slide. I think I dropped it this year, but because I've been getting so many good programming type questions. I always say like statistics is a programming language for statistics, but kind of takes on programming a little bit first, because and my argument for that is the null takes on the programming meaning of null, not the data meaning of null, which is why we use NA and R to represent missing values. If you set a piece of data to the word null, you're going to be very sad. It's just actually going to wipe it out. It actually deletes it from memory. So NA is the absence of a value, where null is actually null. It's gone. So if you want to, in base R, if you want to get rid of one column, you can do, data frame $ column equals null, and it will delete it from your data frame. All right. Group by. So here, this is using the summarize function. I'm still kind of new to this approach, but so I'm going to say I want to group by theme group, and then I can pass that to summary and call things like mean, standard deviation, mean, then n, and I get this table. And so you're going to see in my slides, I'm going to use this approach still because I like this quite a lot, particularly because of this describe by, and it just kind of does it all at once, even though it's kind of the old approach. It is in this package called Psych. So describe, I pass in my vector, I get almost really all of the variables or the measures that I would want, right? So I have n, mean, standard deviation, median. Trim mean here is it takes the bottom 10% and the top 10%, cuts them off and calculates the mean for the remaining piece. So trim means are really a great way to see about spread and also skewness. So we could see the trim mean is $8, I guess this would be $8 less than the full mean. And when we start looking at some plots, that'll become obvious as to why, and some measures of skewness. But the describe by function is really, right? So here's I want to summarize the retail price by some categorical variable, right? And so it gives it to me all at once. One little tidbit, I always use this MAT equals true, which means return it in matrix form. Otherwise, it returns it in list form. And so I often save this into, so this becomes a new data frame that I would use to plot. And so you're going to see this throughout the semester. I'm going to use this function quite a lot. And here I'm just saying I don't care about the skewness measures, and I did that just to make it fit the slide. All right. Wow, we got like 7 minutes, so I might go a little long. So if you have to drop off, I won't be offended, but I do want to get through ggplot. Are there questions about this reshape? I didn't want to spend too much time, and I spent more than I think I intended because I don't want to, I assume you're going to do more of this in 607, but we needed some of the basics. All right, ggplot, data visualization. So, so ggplot is based upon Wilkinson's book from 2005 called The Grammar of Graphics. Is originally developed by Hadley Wickham as actually part of his dissertation work. And the idea here is that we're going to try to build up our plots in layers, right? And this sort of grammatical way. There's as for completeness sake, I have here, there's 3 different ways that you can do create ggplots. There's a qplot, which is really meant to be a drop-in replacement to the functions that are in base R. But I tend to find it's very limiting, so we're not going to really talk about it too much. Another approach is we start with like this ggplot expression, and we'll talk about what that component is. And we can add layers and code them explicitly. Like, so you can actually get down to the graphics layer. So if you're a programmer and you actually want to manipulate down to the pixel level, you can do that. Again, that's pretty advanced. I think everything we're going to want to do, and everything I typically want to do, is this approach where we start with the ggplot, and then we're just going to layer on geometry types. So the parts of a ggplot statement. So the first is that ggplot function call, which is the first parameter is going to be your data frame. And then we have this AES, which is short for aesthetics. So we're basically defining the mapping of our plot, right? So very often you're going to have an X and a Y, right? So if we're going to do something, right? So we tend to have two-dimensional plots. So we're going to have at least those two pieces. Then we can define our layers, right? And these are kind of the different types of geometry. So we have points, we have histograms, there's a lot. So this is sort of the bare minimum to get a plot done, right? We're going to have some data and we're going to have some layers. But then we could do facets, right? Faceting is going to allow us to, chop the plot up into separate plots with subsets of the data. And I'll show an example, so you can create a lot of plots really quickly by just adding a few characters. There's some scaling. So you could do, a log transformation, or if you want to modify the default color schemes, right? This can all be done through the scales. And then lastly, you have your options. You have things like titles, you have the bounds of your axes, the axes labels. So like I said, there are 52 geometry types built into the ggplot2 as of an hour ago when I built this slide deck, right? Or at least the current version of ggplot2. Again, here's a link to the ggplot2 cheat sheet, which I think is really fantastic because I got these little icons that kind of represent the different plot types and tells you what the geometry type is. But to get started, right, here's one of the more basic plots we can create. So we're going to use the Lego sets, right? So that's telling ggplot that's our data, and we want to plot the pieces variable on the x-axis and the US retail price on the y-axis. So this just sets up the relationship between the data and the variables. And then what do we want to draw? We want to draw points. And this is what we get, right? Now, maybe I want to, so I want to color the points based upon the availability. Well, that's just another piece of the aesthetic. I didn't change anything in the point. I just kind of defined another component that goes into it. And so adding just this little bit, I get a new plot that actually adds in a third variable, a third piece of information. Now, maybe I want to consider size too. So I can size the points based upon the number of minifigs that are in that Lego set. And so you can see in the legend, right? So the bigger the point, the more minifigs that are included in that data set, right? So this is kind of clustered down in the end, but a lot of cases can be, this is actually, I think, pretty informative in and of itself. I see we have some potential outliers. Most sets kind of fall down here in the, less than 500 pieces or less than 1,000 pieces, I guess, right? But to kind of pull this out, maybe I want, that availability, the color is kind of getting lost. There's too many, this is almost too many categories to really be effective use of color. So let's just break them up into separate panels, right? So here, I notice I took the color off the aesthetic and I added facet wrap. This tilde, we got a little bit of the formula notation. Just put it in for now. We'll talk about the formula notation when we get to regression. But so we just have availability. So we see now we get, what do we have? 10 different panels, right? And to me, this is also pretty informative. So we can see, oh, geez, some of these availabilities are pretty rare, and right. And so as I'm going to do my analysis, I probably want to do something about that. All right, so here's the box plot. This is also one of my favorite plots. I rarely do it with just one group here. This is US retail price. So this is pretty clear. There's an outlier. So if you're from a box plot, if you don't remember, the box is the interquartile range. So 50% of the values fall within this box. So then 25% are kind of falling above, right? And the way this works is this whisker here is 2 times the interquartile range, and then any values that fall beyond that will be plotted as points. Those are potential outliers. You have to decide. These are, I think they're clearly outliers. The line in the middle of the box is the median. So you'll see some plots later in the semester. I'll do the box plot and I'll actually superimpose the mean and standard deviations or standard errors on top of the box plot, which I think can be quite useful. This is where I think things get really useful, particularly when we do things like ANOVA or chi-square tests. So here we have the availability here, and so we can kind of see the distribution. So we see, educational sets are clearly I mean, we'll do some formal statistical testing later, but it's clearly more expensive on average than everything else.
Well, Professor, I had a question on the last plot there. That the x variable that you have there, availability, that's a vector on its own of all of those x coordinates.
It's yeah.
Or is that a column in the original?
It's a column in the data frame. It's a categorical column.
Okay, thank you.
Yep. All right. I often present my box plots this way, so I added chord flip. So this is one of those options that I think is pretty handy, because then I can read these without turning my head. Here's the histogram. Great. We're going to look at these a lot this semester to evaluate distributions. Here, one thing you need to be aware of is you don't see the warning that I got. So by default, it will try to divide or create 30 bars or bins for the histogram of equal width, and that's kind of determines the height. You often want to play around with that. So there's a bins parameter to the geom histogram. And then here's the scaling, right? So because this is a skewed distribution, you'll see a log transformation often will help make these positively skewed distributions look a little bit more normal. Kind of get these weird dips here. And again, that, playing around with the bin width, might get that. Or, okay, here I did the faceting, or looking at density plots, right? And so you can draw a bunch of these, but we see it's skewed for almost everything, because we have one set that's $800 and another that's $600. Again, this is going to be for reference. We'll look at how we're going to interpret these as we go through. This is a chart I found fairly recently, which I find really helpful. I know it's really tiny here, but when you post the slide deck, you can click it and make it much bigger. So this is, can I make it partially bigger? Yeah, here we go. Okay. So it's a cheat sheet for the aesthetics. And so here along the left side, we have all the different geometry types. So if we were looking for geom point, I think it's alphabetical. Actually, I'm going to do something. Let's look at box plot, right? So the aesthetics that are going to be necessary are the required aesthetics are these blue circles, and the yellow rectangles are optional. And the green triangles, I believe, are things that you can set, but not inside the aesthetic, right? So for a box plot, you can define the width of the box plot, but it can't be variable. It can't be determined by a value in the data frame, if that makes sense. It just has, you pick a width. And width is generally something between 0 and 1, right? Do you want it to be a full width or half width? So for a box plot, you need to have an X and a Y, but then you can also, the fill can be determined on another variable, the alpha, which is the amount of transparency of line type, size, color, group, right? So these, and X and Y, these are kind of key ones. And you see these are kind of some other ones a little bit more, infrequently. Obviously, you see things like font face and font line and family are only going to be used for labels and text, right? So anyways, I find this pretty helpful, particularly to get started, to see like what aesthetics do I need to have for this geometry type and which ones are just optional. Excuse me. Where are we at? Okay, I'm sorry, we're going a little long. Likards. So this is a package I wrote, so it's kind of shameless plug to use it. Here, I'm just going to use a data frame that's included in the package. These are reading attitude questions from the Program of International Student Assessment. So the way this works is, so this is a data frame that just has the items. Each stem or each question is a column. And so they come in coded like this. So this is question 24, part 1. You can kind of think of it that way. So I'm just renaming the columns to the actual stems so that they're, boy, why am I keep doing that on my trackpad? I am so sorry. Okay, here we go. Right. And so once you have your data set kind of in this format, so again, this is tidy data. Each row represents a student's response. Each column is a variable. I'm going to pass that into the Likert function. There's a summary function for it, which gives you the numerical results, but this is kind of my preferred way of looking at Likert response data, because now I can see each response in these colors. And this one's centered. They don't always have to be centered. You can adjust the centering. So there's a lot of options. So I'd be happy to talk in more detail if you have a data set that you want to use this. I'm going to skip over these. All right. Are there many people here in the finance world? Maybe you can speak up. I don't want to spend any yes.
I work for a repo desk.
Okay, so do you typically find or see a lot of dual scaled, or do you know what I mean when I say dual scaled plots? Okay, here we go. Why is this?
I work with market curves a lot.
Okay.
So we have terms and rates, and it's fairly continuous, interpolated.
Okay, so
like yield curves.
Yep. Okay, so that's not quite, but similar. So here, I find like a lot of times you see plots like a line plot, right? So we have time on the x-axis, and then we'll have stock price and volume or trading volume, right? And they plot them on the same. So it's dual scaled. And one of the issues is that, so if I pick this point right here, so the X value is 1992. What is the Y value? Is it 0.7 or is it 70, right? Because what we have here is in the red, we have New Zealand to US dollar ratio, exchange rate. And then we have this, this trading indicator, right? The volume of trading, right? And so I think people who create these plots want to show, is there a relationship between the New Zealand US dollar ratio and the trade volume? And the issue I have with these is like this, I would say clearly looks like, yeah, there should be a relationship. But if I can manipulate, the axes, right, to something like this, that sort of obfuscates that relationship, right? Somebody who sees this quickly might say, well, the trade looks kind of somewhat flat and we got a lot of variability here, right? So the problem is that, my choice in scales on the y-axis can really influence one's interpretation, where what they really want to say is, well, what's the relationship between, the New Zealand US dollar ratio, and, so here each point is a year, and we could see, well, yeah, there is a relationship there. In fact, the correlation is, 0.88, pretty large. So if you find yourself in this situation, to me, there's kind of one way you can get around it is kind of eliminate the choice of scaling by converting everything to a z-score. And we'll define z-score when we talk about correlations, but in short, a z-score is a metric such that the center is 0 and the standard deviation is 1. The center is 0, the standard deviation is 1. And so if in the case of these metrics, so a z-score of 0 means the mean New Zealand US dollar ratio is 0.63, right? That's the mean value. I know it's kind of small, I apologize. Right, so 0.63, the mean trade is 65.77. So anything that's at the mean falls on this line. And if we go one standard deviation above, and so we're kind of equating that. And so to me, this is a safer way of dealing with what we call dual scale axes. Okay, yep. All right, so there we go. Last topic. I think this is the last topic. Pie charts. So if you've been scanning through the textbook, you'll find exactly one pie chart, and there's a good reason for that. And so let's start with this plot. Just take a second to yourself and see if you can just figure out what the difference between these three pie charts are. Is there a systematic difference between these, or are they all just roughly the same? And if I show you this, does it become a little bit more obvious that
Mhm.
what the differences are, right? So this is, I actually stole this from the Wikipedia page. A famous statistician of the last century, John Tukey, I love this quote, said, "There is no data that can be displayed in a pie chart that cannot be better displayed in some other type of chart." So I have very few absolutes in my life. You know, I'm a statistician. I study uncertainty and, you know, measurement error and what have you. This is one of the few absolutes in my life. Never use a pie chart, ever. There is always a better way to display your data. So if you love them, great. There's some people who love them. I always say there's better charts. Just don't use them in this class. You know, and there's, if you're interested, do a little bit, you go to the Wikipedia page, there's a lot of great references. There's a lot of great like perception literature. Human beings are really hard. I have a real hard time comparing arc angles, right? Versus just a linear comparison that's done here. We're actually often pretty bad at comparing areas. So, you know, comparing the area of each wedge. So, you know, there's sort of these human perception issues that we have with it, but it's also, you know, there's this notion of chart junk, right? Edward Tufte kind of famously says it's like the most ink for the least amount of information, right? So when the way he evaluates kind of sort of a leader in data visualization, you know, so this chart junk ratio. So you want to create a plot that uses the least amount of ink that provides the most amount of value or information, right? And so pie charts just kind of fall into that situation where we have a hard time perceiving them. There's a lot of ink, and you know, there's just always a better way to do it. All right, so I have some links here if you want to dig in more. Some of these are on the website. Of course, I highly recommend the R for Data Science book as sort of a companion as you're going through this, and 607. I imagine it would be useful. And then the last thing, you know, if you could do 1-minute papers for me, I'll throw this link in the chat so you have it now, so you don't have to wait. It's oops, somehow I'm on one person. Hold on 1 second. There we go. And thanks for sticking around. Went a little long tonight. I'm willing to stick around if people still have questions.
Just one quick question, Professor.
Yes.
The 1-minute paper is different from the sheet that we have to fill out at the end of every class?
No, that is the sheet at the end of each class. Yeah, it's called. Yeah, don't spend much more than a minute answering it.
Thank you, sir.
Professor, I have a question.
Yep.
For homework 2, I downloaded the PDF file, but I'm not able to open it. I don't know if it's corrupted or what's going on.
Oh, let's see here. I lost my. Let's see here. Homework.
Yeah, chapter 2, the PDF.
Huh, it's viewing on GitHub. Let me
Chapter 2 PDF.
Yeah, it's opening up for me. Is anybody else having an issue?
Oh, okay.
Yeah, I didn't have any issues with it.
Yeah, I mean, it actually is viewing, right? This is in GitHub, right? It's preview.
Yeah, okay.
Yeah.
I'll try to get it directly from my GitHub. Sorry.
Yeah. Well, just
I
click.
just right-clicked on the.
Oh, right. So if you right-click this and say download, it's actually an HTML file, not a PDF.
Okay.
Click
got it.
this, and then here's the download button.
Got it. Okay, thanks.
Yeah, sorry. Because I just assumed most of you would download the template, because you can just write your answers in here. But whichever.
We can also do the RMD file, right?
Yeah, that's what the template here is, the RMD. So if you right click this, you can download that linked file, and that's what I would recommend doing, but it's not necessary.
Just run that file in the RStudio.
Yeah, the template is technically what built this PDF.
Got it. Mm-hmm.
Yeah.
And,
It just builds it only builds the PDF though, because like the tables are in LaTeX format. So if you're having trouble building LaTeX, either reach out to me or you can just type it in another document. And the problem is also that the CUNY Blackboard doesn't allow HTML uploads. So you can always knit. I should have said this earlier. If I didn't, I apologize. You can always knit to HTML and create a PDF like from your web browser. I'm totally fine with that. Yeah, Word works. Yeah. Yeah, you can upload Word to Blackboard. Any other questions?
Any feedback on the homework would be appreciated.
Yeah.
I'm a little nervous about it because this is all new to me.
Yeah, sure. I apologize. I got a bunch of time blocked tomorrow to grade. I had some things come up.
I mean, you could just skip past reading them and just give me a good grade. And I'll be
No, I will look at them tomorrow. Yeah, no problem. Anything else?
Nope. Have a good evening, everybody.
Yeah, you too.
Good night.
Good night.
Great.